This screen cam is looking at using Wireshark to analyze HTTP. Inside here we have a pre-canned demo, a set of files or set of frames automatically related to capturing specific traffic. So let's see what we can find. Several things we need to do here. We need to know what's going on inside this capture. We could scroll down and find lots of information about what's happening inside here, but when you're looking for a needle, a haystack's not a good place to look. So let's see how we could do that. Simply, we could click on protocols. We can now see a great deal of ARP requests, we can see some browser and DNS. Scroll down further, we can now see HTTP frames. We've got the option now of analyzing through these HTTP frames individually or using the tool to analyze them for us. What I'm going to do here, the first request was to www.apple.com, so someone was going to that address. We then appear to have a response from DNS for the same thing, for Apple. So I want to know what frame comes after that. So I'm now going to go back into a sort for this frame, and we've got some ARP frames. Well, they're not particularly important to us in this case. We want frame 6. Frame 6 is a SYN frame. SYN-ACK is in frame 7, and ACK is in frame 8. So we've got SYN, SYN-ACK, ACK. If I pick the first frame and follow the TCP stream, we're going to find out what content is there. If I just move this window out of the way and go back to this window, we see that we've got this complicated display filter that's been written for us. The filter, the display filter, has filtered on 2 specific IP addresses and 2 specific TCP ports. That's how it's used, or that's how it's generated these unique frames. As you can see, there are only several frames here that are to that particular address. The first part is a GET, so we're trying to request information from using our web browser. We see that we tell the web server a lot of information. We say we're Mozilla 5.0 compliant. We're running Windows, specifically Windows NT 5.1. You find out that 5.1, if you Google it, is Windows XP. Our browser is apparently Apple WebKit 5.22.15.5. That sounds a bit strange. Let's look a little bit deeper. It then says Light Gecko version 303 Safari 5.22.15.5. That's the key. The key word here is Safari. I'm obviously using the Apple web browser, or a beta version of it, running on Windows XP. So I found out a great deal of information just by analysing that. If we look at what came back from Apple, we see here the server type. This is quite important information. Apache 1333. We know the type and version and subversion of Apache. We also know that they're running server-side scripting, PHP 5.21, and we know Darwin. What does Darwin mean here? Well, that's actually a compile string. It means Apache has been compiled on the Darwin platform. Darwin is the kernel that's running inside Mac OS X. So we now know a great deal about the servers that are serving websites at apple.com. We also see here Xcache miss from Ricksgate. I'm running some kind of firewall or proxy firewall, and Xcache miss means that it wasn't present in that capture. So this is the first time I've been to that web page. So that's just one quick capture, and we found a lot of information. Let's clear that capture, and we'll move on a little bit deeper into this capture analysis. Okay, I'm picking a random frame here, and I'm going to follow TCP stream. What we see we're trying to look for now is prototype.js. Looks like some sort of JavaScript that's being downloaded. Again, we've told it a lot of information. Here we receive some information about the server again, but now we have some new information that's come back. Xcache time. We've got a hit on our proxy. That means my web server proxy or firewall or whatever it is has actually already cached this web page, and it's valid for a certain period of time. If I scroll down inside here, we start looking at the HTML or JavaScript or whatever it is inside this page that's actually been passed down back to my web client or my browser. All in blue means it's come from the server. Anything in red means that's information that's come from my browser out to the global internet. So you can see every now and again you leak, or you request information and you leak details about your operating system and platform. Again, we've got complexity in the top here in display filters, ip.adra.equal to 84.53.175.41. So that's obviously a public IP address, probably in the domain of apple.com. And then we've got a local private address. And we've got some port numbers here as well. If I clear that, we're back to where we were. So that's an analysis of HTTP, and you've seen some of the basics of what you can see inside this capture. There are many other things we can do inside the Wireshark tool. We could do a protocol hierarchy tree and find out what information is here. This basically gives me a statistical breakdown of what the frames are. The frames are all Ethernet. They're all 99% are IP, some of which will be ARP, they have to be. Inside IP we have 2.4% or 4.49 being UDP and 97.18 being TCP. So we're breaking down those protocol stacks quite statistically, which is handy to know. We could also do things like an I/O graph, and this is looking at the peak traffic going through the network coming in. This is important because when you view a web page you realize that you're going to different pages, you're receiving different blocks of information, and you require large bandwidths and then virtually nothing in between. There are other kinds of analysis we could do here. For example, we could look at a flow graph, TCP flow or general flow. If we look at general flow, here we can see that we've got different end stations talking to each other with their requests and their responses. Okay. Maybe better if we don't do that statistical analysis, if we do TCP flow. Have a look at that. Here we can see the traffic: SYN, SYNAC, ACK, PUSH-ACK, ACK, PUSH-ACK, FINAC, ACK, FINAC, ACK. So we've got connection established, exchanging data, teardown session. These are all things that you're going to see in the top-down approach to network featuring the internet, the Q, Rose and Ross book. That's all I'm going to do in this screen